Welcome back. Okay, so one last lesson in the unit on uh, linear equations. So what we want to talk about now are parallel and perpendicular lines. We've got point slope, slope intercept, and standard. So we know how to graph lines now. Now we want to talk about the relationships of lines. And the two most popular ones are parallel and perpendicular lines. So let's start with parallel. Oh, sorry, chapter 3, section 10. So we're going to start with parallel lines. And how do you tell if two lines are parallel? Now, you can graph them, but if your graph isn't big enough, sometimes you can't see. So we want to resort to doing it mathematically. So the first method is if I gave you these two equations, you just realize, okay, well, this is in slope-intercept form. So I've got y equals m, so there's the slope there, y equals 1/2 x plus 5, and this is y equals 1/2 x minus 3. So the two slopes are equal to each other. And if the slopes are equal, then we know that the two lines are parallel. So same slope means parallel. Okay, now what would it look like if that weren't the case? So here we've got y equals 5x plus 4 and y equals negative 5x minus 7. Well, if you look at the two slope values, they are not the same. So these two are not parallel. So we can say not same slope, therefore not parallel. That's probably the quickest way to do it mathematically. But what happens if you get something like this, where you've got one equation in slope-intercept and another one in standard? Okay, well, the slope in the points or slope-intercept version is very easy. M equals negative 1/3. Now over here, if you remember correctly, in standard form, slope equals negative a over b. Okay, so my a term is 2 and my b term is 6. So no, yes, that's correct. So negative 2 goes in the numerator and 6 goes in the denominator, and that reduces to negative 1/3. So here's a case where they were in different forms and you had to do a little work ahead of time to figure out if they did have the same slope. In this case, they do have the same slope, so they are parallel. Okay, just a couple quick ones there. Now, let's get into some of the meat on this thing. All right, so write an equation for the line that contains or goes through 5, 1 and is parallel to y equals 3/5 x minus 4. The only thing that I need from the equation is that slope. M equals 3/5. Now, any line that's going to be parallel to this has to have that slope. So now I've got a point, 5, 1, and a slope that's equal to 3/5. Okay, well, if I have a point and a slope, I'll go through point-slope form. Y minus y sub 1 equals m times x minus x sub 1. All right, x1, y1, plug in the numbers and you have y minus 1 equals 3/5 times x minus 5. And there you go. That, of course, is in point-slope form. And in the last lesson, I showed you how to convert from point-slope to standard to slope-intercept. So you could do that here, because remember, on a test, it might say write an equation in standard form, or it might say write an equation in point-slope form or slope-intercept form. So not only do you have to know how to figure it out in point-slope, you need to know how to convert it from point-slope to the other two forms, okay? I'm not going to show you that here because it was in the last lesson. So we'll just go with this the way we have it. Okay, and that was example Kurt. Just to reinforce it, we're going to do example Liesel. Okay, so write an equation for the line through the point 2, negative 6, parallel to y equals 3x plus 9. So again, my known point is 2 comma negative 6. The line has to go through that, and it has to have a slope of 3. So y minus y sub 1 equals m times x minus x sub 1. And you plug in the x1, y1 values to get y plus 6, because we are subtracting a negative, equals 3 times x minus 2. And there you go. Again, it's in point-slope form, so make sure you know how to convert that to standard and slope-intercept if you have to. Now let's talk about perpendicular lines. So I've drawn two lines on a graph, and these two lines are perpendicular to each other. Perpendicular, another definition, is that they meet at 90 degrees. So what I'm going to do is show you, if I put my triangle up here, which has a 90 degree here, you can see that these two lines are perpendicular to each other. So let's figure out the slopes. Let's do line L first, okay? This is up 1, a rise of 1, and a run of 2. So the slope here equals rise over run, so that's 1 over 2. Okay, no problem. Then let's do this one, where now it's, instead of going up 2, it's going down 2, and it's running 1. So the slope here equals rise is negative 2 over the run, which is 1. So now I want you to look at these two, okay? This slope is 1 over 2, and this slope is negative 2 over 1. What's interesting here is if I go the slope of line L times the slope of line M, what do we get there? What I get is 1/2 times negative 2 over 1 equals negative 1. If two lines are perpendicular, the product of their slopes is always negative 1. So the product of the two slopes that are two lines, let me back up. The product of the slopes of two lines that are perpendicular is always going to be negative 1. So another example might be if one line had a slope of 2/3 and the second line had a slope of negative 3 over 2, that's negative 1. These two slopes are perpendicular to each other. They are reciprocals and they are opposites. One's positive and one's negative. Okay, let's wrap up this lesson. We've got example Fritz. Write an equation of the line perpendicular to y equals negative 1 over 3 x plus 2. Well, I need this slope, but I'm not going to use it the way it is. If the slope that I'm given is negative 1/3, the perpendicular slope, so I'm writing that as m sub p, is equal to, we're going to take 1/3, flip it over, so that's 3 over 1, and if this is negative, this perpendicular slope is positive. So I can just write that as 3. And again, look, negative 1/3 times 3 is negative 1. Those are perpendicular slopes. Well, there's my slope, there's my point. So y minus y sub 1 equals m times x minus x sub 1. Okay, so I have y minus 2, there it is, that's the 2 from there, equals 3 times x minus 4, and that's my x sub 1. So here is the equation of a line that is perpendicular to that line, okay? And again, you want to be able to put it into slope-intercept, standard,